Module 1 Mastery Assignment by Leslie Oy. Topic 1. Common trig limits. Common trig limits are used to help evaluate a function in other mathematical problems as the function approaches a certain x value. One example would be the limit of sine theta over theta as theta approaches 0 would be equivalent to 1. Another common trig limit in calculus would be the limit of cosine theta minus 1 over theta as theta approaches 0 is 0. Here is the graph of the first common trig limit. As you can see, as the function approaches 0 from either side, left or right, the function will be equivalent to 1. Here is another graph of the other common trig limit. In this one we can see, as the function is approaching 0 from either left or right, the value of the function is 0 as well. Let's move on to an example. In this example, we are to evaluate the limit of tangent 4x over x as x approaches 0. The first step we would take is to multiply 4 to the limit while also dividing by 4 as well in the fraction. This allows us to manipulate the limit in order to evaluate it correctly. The next step would be to change tangent into sine and cosine terms. Remember that tangent is sine over cosine, so we can rewrite this as 4 times the limit of sine of 4x over 4x multiplied by 1 over cosine 4x as x approaches 0. After this, we can also apply the limit separately to the 1 over cosine 4x according to the properties of limits. At this point, this is where the knowledge of common trig limits comes in handy. Remember that the limit of sine theta over theta as theta approaches 0 is equivalent to 1. We can apply this here to the fraction with sine. All we would have to do is change 4x into theta, and for the fraction with cosine we could just use direct substitution. This would all simplify to 4 times 1 times 1, which equals an answer of 4. Limits at infinity. Limits at infinity are more commonly known as horizontal asymptotes, and this is where the graph is leveling off at some y value. Horizontal asymptotes are where x is approaching positive or negative infinity. The significance of these limits are they help to determine the end behavior of functions. A rule that could be written for this is the limit of c, a constant, over x to the nth power as x approaches infinity is equivalent to 0. The same could be applied to a limit as x approaches negative infinity. In both of these cases, however, the exponent of x would have to be greater than 0. Let's move on to an example. In this example, we are to find the horizontal asymptote of the function 20x squared minus 3x all over 3x to the 5th power minus 4x squared plus 5. A useful technique to approach this problem is to divide all terms by the highest degree of x in the denominator. Remember, the degree would be the highest exponent, and in this case, the degree would be 5. Now we will divide all terms by x to the 5th power. Remember, when dividing exponents, you are essentially subtracting the powers as long as the bases are the same. Here is what the division would simplify to. Next, we would apply a limit as x approaches infinity to the function, because a horizontal asymptote is letting x run without bound. Remember the rule from earlier that looks similar to these? As long as there is a constant in the numerator and the power of x in the denominator is greater than 0, we can apply this rule to our function. This would then simplify to 0 minus 0 all over 3 minus 0 plus 0, which equals 0 over 3 and gives the final answer of 0.